Robot Talk is the podcast that sits down with robot enthusiasts from around the world and asks them the questions you always wanted answered. Like, is that robot using stereotypes? And how does that thing work? Hello everyone! Welcome to Robot Talk. I'm your host, Claire Asher, and this week we'll be exploring two distinct topics related to human-robot interaction. How to make social robots sensitive to different cultures, and how robots plan to complete tasks in environments shared with humans. Before we get started, please remember to like or rate this episode and leave us a review, if that's something you can do on the platform you're listening on. And don't forget to share the podcast on social media or tell your friends about it. It really helps us reach more listeners, so thank you in advance. So, without further ado, it's time for me to introduce this week's guest. I recently had a fascinating discussion with Masoumeh Mansouri from the University of Birmingham about culturally sensitive robots and planning in complex environments. Today, I'm chatting to Masoumeh Mansouri, an associate professor at the University of Birmingham, whose work focuses on the intersection of cultural theories and robotics. Hi, Iran. Welcome to Robot Talk.
Hello. Thanks for having me.
So, you're studying the potential for cultural sensitivity in social robots, which in theory could make them more trustworthy and likable for the people who interact with them, but in practice is a very complicated thing to achieve. So can you talk a bit about the biggest challenges that are faced in developing more culturally sensitive robots?
So the biggest challenge is in the ambiguity of the word culture. Let's give you an example. If I tell you I have a culture night, I'm going to have a culture night, you may think that I'm going to go to a movie or go to a play, I'm reading a book, or I may say, oh, the culture of computer science department in our university is very different of the culture of a political science department. Or I say, for example, my neighbor, they have a different culture. What I mean by that maybe is they're from different part of Birmingham. I live in Birmingham, that's why I give an example of Birmingham, or from another country. So I can mean really different things when I use the word culture. And even academics use culture, in very different ways. So culture means different things in anthropology, in sociology, in political science, in psychology, linguistic, and I can, go on.
Sure.
In fact, there's a book by Baldwin in 2006. There are more than 300 definitions of culture.
Wow.
So the biggest challenge is which of these definitions, if any, is appropriate for cultural robotic. And and the interesting thing is when it comes to the cultural robotic, when roboticists try to interpret culture for robotic, actually this diversity collapse. So most roboticists, not all, when they use culture in the context of robotic, they mean nationality. And most of them, they use a model developed by Hofstede around 1984, and which is actually quite interesting story why they use that and why this is so prevalent. So, and Hofstede model is designed for a business person. Back in the days, they wanted to go to a business trip. They want to do business with the people from different culture. So they develop a guideline for how to do cross-cultural communication.
Okay.
And this model has, in fact, 6 dimensions. What this dimension does is quantify the cultural code. They have a dimension regarding the power distance, uncertainty avoidance, individualism versus collectivism, masculinity versus femininity, and short versus long-term orientation.
Okay.
And I can give you an example of how this cultural code used in robotic in the context of culture. For example, you can think of a robot that endowed with a cultural model, the cultural model that inspired from this Hofstede model, which I explained. So, according to this model, for example, a Japanese person has higher score in collectivism in
Mm.
comparison to a British person. So when the robot want to have some sort of communication with a Japanese person, it's stand a bit closer to a Japanese person than the English person based on this number. And it's not so difficult to imagine that why this is in fact a bit problematic. So
Mm.
it's basically equate entire nationality and the diversity within this culture to a number, and you program that robot based on that number. But also, it's not that difficult to imagine why roboticists would love that, because you
Yeah.
quantify quite a complex phenomena to a bunch of number that you can easily program robot behavior with that. And yeah, I gave a very long answer why this is complex.
Yeah, I mean, I think you've illustrated well why culture is so complex, and the idea of trying to reduce it down to numbers just seems, like you can understand why people want to do that, but it seems like a little bit of a ridiculous thing to try and do, or at least, maybe you could do it if you had 1,000 dimensions rather than six. I imagine as well, if you try and make a robot culturally sensitive and you do it in a kind of oversimplistic or naive way, that could actually have the opposite effect to what you intend. And it could actually, annoy people or alienate people, make them feel stereotyped.
Yeah, in fact, you're right. So one of my early research is actually trying to criticize this dominant interpretation of culture in cultural robotic. And so when you explain what is wrong, most people agree with you, but how to come up with a model that's actually different from the existing one is not
Mm.
easy. But just give you an example, I want to make sure that explain carefully and quite precisely why this is problematic. It's obviously, as you mentioned earlier, using culture as nationality propagate potentially harmful national stereotype.
Mm.
And it also, when you focus on national culture, we diminish the nuance and complexity
Yeah.
exists in a culture. For example, subculture that can be very different from the national culture. Also, it's morally problematic. It, for example, exclude people who cannot fit to a traditionally major national culture, like refugees, people who do not
Mm.
have, a stable status, immigrant, a religious minority, and also promote the need for assimilation. And it also abandon the historical culture in favor of general culture. You can see actually you want to deploy robot, as you mentioned, to enhance people trust, enhance people the likeliness toward robotic, but you do exactly the opposite.
Yeah.
And my research is this is the starting point of my research is actually from the critical perspective. Okay, this is wrong. I understand why this is wrong because it's quantified and it's very easy to implement that. But we need to seek for a new cultural model, if you wish, to develop it for robots.
Mm. So obviously, this is an incredibly difficult thing to do. But what do you think would be a more optimum way to design and program robots to interact with people effectively, whatever their cultural background, et cetera, et cetera?
So yeah, it's obviously it's not an easy um, problem to approach. So my research is in fact to understand what culture means for robotic. I take one step back
Mm.
and I first try to understand what this diversity means for different area of robotic. And I explore the effect of the use of different types of cultural model into robotic. For example, you can imagine a factory, and your factory in Birmingham, which actually imagine doesn't have that much of a ethnical diversity. The reason I'm bringing an example again, when I'm talking about culture, people always ask me, "Oh, how to use a robot that works in Japan and it works in England?" I'm making a quite totally different example. Imagine you want to have a robot here in Birmingham in a quite without much of a even ethnic diversity, even the notion of culture would be relevant there.
Mm.
And this robot, for example, you want to collaborate with a human on the task, and the question would be here: what culture means in this particular human-robot collaboration?
Yeah.
And so, if you want to have a robotic in a museum, and the robot guides the person in the museum, explain the artwork, what culture means in
Mm.
that context. And obviously, as I said, I start approaching all of this problem from the critical perspective. And it's important to mention that. So when you bring a robot to a workplace, to an environment that already only was belong to human, that presence of robot gonna change the culture.
Mm.
So one of my study is to understand how the new form of culture created between human robot interaction is not just the looking at the existing human interaction and replicate it with the robot. We have to understand that bringing the robot is actually change the dynamic, and what are the implications of that, what are the impact of those culture, good or bad, but we have to try to understand this.
Yeah.
And back to your question, precisely what my group and my research collaborator, particularly I'm collaborating with Dr. Henry Tyler, he's a philosopher.
Okay.
We try to develop a framework to take into account relevant properties of a task that the robot needs to do, and based on which we give a guide to different stakeholder that wants to design a culturally sensitive robot for a different application. And this framework could involve in asking certain questions that a different stakeholder, a designer, a roboticist, a person who want to buy this robot or deploy this robot, should think of those questions. For example,
Mm.
uh, the location, the basic context that the robot needs to be deployed, the overarching goal. Back to example of the robot in a factory, the task, if it's an assembly of certain object, that would be overall goal. And then we need to think about the cultural norms, and how many humans does the robot have to interact with. For example, again, in the case of that the factory, there is one person, but imagine if you deploy a robot in the museum, the robot needs to interact with many people. The kind of cultural perspective that the robot needs to have is different in these two cases, because in one example, the robot needs to deal with the cultural norm of really one person. If it adapt to the preference of that person, it would be culturally sensitive to the behavior of that person. That could be acceptable
Mm.
potentially. But if you're dealing with a large number of people, which could be really diverse from a different perspective, another interpretation of culture is relevant. And social science give us, as I said, a wealth of different interpretation of culture. And the question is, which of them is relevant to this, which of this application, and what question need to ask, and what is the computational equivalent model of those definition or interpretation of culture in social science.
Yeah, that's a lot of really good points. Yeah, it makes sense that this would need to be tailored to the job that the robot is going to do. It would be, yeah, really oversimplified to try and have like a one size fits all policy. And yeah, I was thinking about the capacity for robot learning, and like becoming sort of tailored to an individual person, which probably works great if it's a robot that's going to help you out in your home. But yeah, your museum robot example kind of points out the flaws in that when it needs to interact with lots of people. Um, it's really really interesting, and I guess maybe roboticists need to be. I know a lot of them already do, but roboticists probably need to think about interacting more with social scientists and trying to bring more of that research into their work.
Yeah, well, whenever I talk about this, I kind of defend robotics and sort of criticize them at the same time. So I gave already the criticism. So why this is problematic? For example, the recent survey comes on cultural robotic. The only definition it's been used is nationality.
Mm,
Again, it's not. It doesn't mean that no people doesn't look at the other definition, but it's very rare. But at the same time, so quantifying and a very, very contextual, vague, qualitative definition when it comes to culture or another concept, it is difficult. And the question we should ask is whether the state of the art AI has the epistemological adequacy or computational adequacy to represent those. And in fact, I wrote a paper like I think 2 years ago. I called for this. The whole paper was about the call for looking at different AI method,
mm,
different variation of machine learning and the logic-based knowledge representation and reasoning method in AI to see which of them or combination of them are adequate enough to represent this complex topic. And I don't have the answer, but I think we don't even ask this question.
yeah.
So we are looking at, okay, we have this amount of data and what kind of machine learning tools we can use to learn certain pattern. But we should step back and as you mentioned, we should interact with social science and we look at those definition with the lens of AI method and see whether or not they have the capacity to represent that. And if not, what is the boundary? And yeah, that should be a starting point, basically.
Yeah, really, really interesting area of research. So you're also working on developing hybrid robot planning methods for unstructured environments shared with humans. So first of all, what is a hybrid planning method, and why is this a useful approach for this kind of environment?
So I am my main research area. In fact, is quite old. I started working on that during my PhD onward. Is on hybrid planning,
Mm,
and I can explain what hybrid planning means by example. First, I use a human myself as a robot
mm,
to express, and then I translate that to a robot. So imagine I'm going to make a porridge for breakfast, and
mm,
I have to leave my home, to catch a bus or something at a certain time. There's a deadline involved, and I wake up at a certain time because I have an estimate of how long does it take to prepare breakfast and eat it. So I pick a bottle of milk from the fridge, get an oatmeal from the a cabinet, a spoon, and put all of the item required to make a porridge on the counter, and then mix things together in a certain order. Some of the things has to be done in a certain order, and eventually eat that. And now imagine the robot wants to do this. Robots should do the similar things.
mm,
It needs to have an estimate of when needs to start making a porridge. Basically, it has a reason about the time because there is a deadline involved, the duration approximately each task can take place, and those tasks could be varied. There is a person need to, I don't know, take something from the fridge and kind of obstruct the robot's
mm,
path to do that. So it needs to think about this time. It needs to think about the task itself and the order of each action it requires to do to perform the overall task of making porridge. And similar to me, the robot also has to pick up the milk and the oatmeal from the cabinet or things of that sort. And it has to come up with an order, that makes sense to make a porridge. And that's in the robotic field usually called task planning. So you have to reason about the order in which an action needs to be done in order to fulfill an overall goal, in this case, making a porridge. But also, the robot needs to reason about its own motion to perform each individual task. It has to think about how it has to open the door of a cabinet, how much force it has to use, given the kinematic and dynamic constraint of the robot's arm, so the physical constraint the robot has, how it has to open the door of a cabinet or the fridge. So this in the field of robotics usually called motion planning. And in order to fulfill the task of making porridge, you have to combine this reasoning about motion, reasoning about time, and reasoning about a bunch of other things to fulfill the overall goal. And that is what hybrid planning about different things, planning about time, planning regarding to motion, planning with regard to the order of actions and so on. And it's challenging. So, and I guess your question would be why this is difficult and why this is useful. Again, it's useful, again, as the example, as I mentioned, but imagine your oatmeal is on the back of the cabinet. So you have to push things around or remove something from cabinet in order to reach it, like a human does. So for a robot to do that, it needs to, again, reason about which object needs to be removed, how to remove it, basically has to reason about the motion and the task at the same time in order even to reach the oatmeal at the back of the cabinet. And that's a combination of this reasoning. It is a difficult task because in robotic or in computer science, the way that this knowledge is represented is different. They have different level of abstraction. So they're using differential equation for motion. You can maybe use logic or different sort of machine learning based method to reasoning about action. And combining this is not trivial because the language you use to model this knowledge is different. And combining them, it is challenging to produce a coherent, consistent, and feasible robot behavior.
Yeah. And I guess it gets more complicated the more kind of complicated the environment is. Like I'm thinking of, things where you go to do one task and then there are 5 other things you have to do first. I'll go to make dinner and then I realize, okay, I can't make dinner yet because I have to unload the dishwasher. And then I can't unload the dishwasher because something's in front of the dishwasher that I have to move. And it kind of spirals out of that. And I can imagine it getting very complicated very fast.
Exactly. So I used to work with the robots in unstructured environment like mine, like construction site. And the example of home actually is a more difficult one. Our homes are much, much more unstructured than anything else. But as for the real example that I've used for mine, so there's a lot of uncertainty involved with respect to the environment. And you have to reason about really all of the things that you have to think about in the case of porridge. Also, your perception is limited. The ability of robot to exactly reason about where it is, this called localization problem is limited. So you have an additional complexity when it comes to an unstructured environment. Or imagine the robot in that museum that you have to pass through a crowd of people in order to approach an artwork. And that's certainly not easy because people would, constantly move and obstruct the robot. And if you have a tool which has a deadline, you have to think about, okay, how I should navigate through this human to make sure that I cover enough artwork and or the important ones to reach the deadline. Usually the tours in the museum has a deadline. So you have to think about all of this thing at the same time, hence hybrid reasoning or hybrid planning. and is unstructured, because it's different certainly from a robot assembling things in a factory where there is no obstruction, or there is a fixed model you have to do. You have to repeat a certain task.
Yeah. And then we've got a kind of related audience question from Craig Lawton Devine on LinkedIn. So Craig says, I'd like to hear Iran's thoughts on the problem of mischievous people who might interfere with an otherwise optimal plan.
You're right. So I don't think that you need to have bad people that your plan goes wrong. Your plan goes wrong for even, with 1,000 different reasons.
Yeah.
And your plan goes wrong. It could be, in the museum example, because a bunch of kids playing in front of the robot, so they're not moving away, and they're not probably even not aware of that the robot are not moving away because of them. So that question is very relevant. And in fact, I'm involved in a big European project called Convince, is dealing exactly to designing a cognitive deliberative robot system that is robust, essentially. And I'm leading a work package on hybrid planning with uncertainty, which the result of that research would be exactly answering to that question, meaning that if you have a plan and you want to perform it, and a lot of things goes wrong, a lot of things that you can imagine can go wrong is a known anomaly. Then when you write your algorithm, you take into account those known anomaly. If things happen, you perhaps want to do this and that. But there's a lot of things can happen that you can't even predict, unknown anomaly.
Yeah.
So you have to endow robot with the mechanism to understand what has been goes wrong. It basically does some sort of root cause analysis of what has been goes wrong, and can get out of those situations, again making a new plan, or do some sort of information gathering to see what I can do next in order to fulfill my goal. And this is an active research. In fact, is that question relevant to my research within this project? And in robotic, really doesn't make sense that you have a plan that doesn't deal with uncertain, unstructured environment, because a lot of things can go wrong even without having people with bad intention around.
Yeah, definitely. Yeah. I guess the slight difference maybe with someone who does have bad intentions is that, they do something to you, you come up with a new plan, but they're always trying to kind of counter that. So this sort of almost becomes a game of chess.
Yeah. There are research in AI, they can actually intentionally in design, they consider this kind of attack intentionally and try to devise a strategy. I personally don't do that. So my research incorporates planning for uncertain environment, and it has to deal with the situation when things goes wrong. But I do not explicitly incorporate those malicious attacks in my robotic system that I'm designing. Perhaps I should, but already the task in itself is difficult.
Yeah, I was going to say, I think you've got plenty to be thinking about already. So, Iran, it's been lovely talking to you today. I've been speaking to Masoumeh Mansouri, an associate professor at the University of Birmingham. Thank you.
Thank you.
Thanks for listening. If you enjoy Robot Talk, please do share the podcast, subscribe, and leave a review to let us know what you think. And if you've got a question you'd like me to ask one of my future guests, you can contact us on social media at Robot Talk Pod or visit robottalk.org. And don't forget to enter our t-shirt competition for a chance to win your very own Robot Talk t-shirt. All you have to do is share your favourite episode on social media and tag us at Robot Talk Pod. Next week, I'll be talking to Jorvon Moss from DigiKey, about making robots at home and robot design and aesthetics. Until then, I've been Claire Asher, and this has been Robot Talk. Robot Talk is brought to you by the Hamlin Centre, Imperial College London.